It's a pleasure to be here. That's my first luck. I'm going to present a paper made by many hands by Gian, Raissa, Anderson, me, Rafael, Vitomir, and Dragan. And the paper is entitled Towards Automatic Cross-Language Classification of Cognitive Presence in Online Discussions. Well, here's the outline. I will present the introduction, some related works, our research questions, the method, results, conclusion, and some future work. The number of online and blended courses has increased very fast, and they are a fact nowadays. In these environments, we have many resources, including asynchronous online discussions. And this research specifically is used to support social interactions, make students interact with each other, share questions, share resources, and promote pedagogical practices also. Well, the community of inquiry model is a very used and validated model, and this model provides a better understanding about the experience of the student in online learning, okay? Well, the central element of this model is the cognitive presence, right? It's very important to know about this because it can help us to understand the development of the students about the skills that the students wants to develop. Okay, so this cognitive presence can be divided in 4 phases. The first one is the triggering event. In this phase, we are focusing in the problem inception. The second one is the exploration, which is the idea generation, the exploration. The third one is the integration phase, where we synthesize relevant knowledge. And the last one is the resolution phase, which is the application of the acquired knowledge to the starting problem. There is a task that is classify discussion messages in these phases. It's not an easy task, okay, because a single message can express different phases. There are some works that are dealing with this problem, trying to classify discussion messages in cognitive presence, okay? And it's very important because it can help us to evaluate, and having a good evaluation, we can improve the experience of the students in an online course, right? Here we have a table. This table shows a comparison among the different works that we have, that we found. And the first 3 works developed by McLean et al., Kovanovich et al., and Waters et al., they used some machine learning algorithms to classify discussion messages following these features in the 3rd column, right? In the last column, we have the performance. These all 3 works had faced a problem related to the imbalanced behavior of the dataset. When we have a discussion message dataset, the messages, the amount of messages in each phase may vary, right? So the nature of the dataset commonly is imbalanced. So these 3 works had faced this problem, didn't deal with this problem, and point out this problem as a limitation in their works, right? In the later 2 works, they dealt with the imbalance problem using SMOTE. SMOTE is a sampling algorithm used to balance the data set. The SMOTE is an oversampling algorithm and it increases the number of instances of the minority class to balance the data set. The work developed by Cohen used this sampling algorithm to balance the English data set, trying to classify the discussion messages. The last one was performed by Neto, and Neto et al. Used a random forest and an SVM or machine learning algorithm using these features. They also use mode to balance the data set, and the result was promising too. There are 2 points, very important points here. Balanced data sets is an important step in the process of classifying discussion messages. And another point is in the last work developed by Neto et al., they had to label manually all the Portuguese data set. Most of the works, the majority works that we have found in literature are in English, have an English data set. So if you want to work with data sets with different languages, we have this step of labeling the data set. So here we have some research questions. The first one is, to what extent do cognitive presence classification models generalize across different languages? Can a cognitive presence classifier trained on a corpus in the English language be applied to a data set in another language? So this question wants to investigate if it's possible to train a classifier in a language, for example, English, and test using the previous knowledge in a Portuguese, for example, data set. Can it be possible? So in this work, we want to answer this question. The second research question is, which classification features are the most predictive to perform this task? Okay, so we are interested to identify the features that make the first, that give us a good solution for the first question. And the third one is, to what extent can the state-of-art class balancing algorithms improve the cognitive presence classification, right? Are we sure that smooth or classical sampling algorithms are enough to help us during this task? Do we need to create another sampling algorithm to fit our problem? Well, let's talk about our method. At first, let's present our study data, right? We selected 2 data sets, okay, from previous studies. The first data set is an English data set from Cohen, and the second one is the Portuguese data set. Both data sets from the first from 2016 and the second one 2018. Well, here we have the distribution of the messages in each data set. As you can see, we have an imbalance scenario here. We have 4 phases, 5 classes, 4 phases of the cognitive presence, and the another phase in the another class is other, right? When we can't match in the 4 phases, we have an additional class for that. As you can see, this is both data sets are in balance. The other triggering events and resolution classes, they have fewer instances in comparison with the other classes. And perform sampling, execute a sampling algorithm may be important in these cases. Okay, about the feature extraction, we adopted the same 5 classes from Cohen, learning, inquiry, word count, Coh-Metrix, discussion context, layered semantic analysis, sentence similarity, and number of named entities, right? It's important to say that in the paper published by Cohen in 2016, they considered 205 classification features, right? But as we are dealing with a Portuguese data set, as we are using a Portuguese data set, there are some limitations some limitations regarding the LIWC and Coh-Metrix implementations. So we use just 108 different indicators for both data sets. Okay, the classifier. We use the random forest classifier for this work, but our choice was supported by a work developed by Fernandes Delgado et al. In 2014. In this work, they tested different classifiers in different problems, and they concluded that the SVM and the random forest are the top performing general purpose classification algorithms. But as we intend to investigate, to interpret the results, we decided to use the random forest algorithm. About the data preparation and preprocessing, focusing in training and testing dataset. Our dataset is already split, right? Because we are training our classifier in the English dataset, and we are testing the classifier in the Portuguese one. Right. Regarding the imbalance problem, the table 2 that I showed you earlier, table 2 showed that both datasets are imbalanced. There are many algorithms for sampling, oversampling and undersampling, right? Near miss, OSS, random undersampling, SMOT, right? But there is a work that was published in 2019 by Barbosa et al. And in this work, they say that the combination of different algorithms, sampling algorithms, can produce better results than standalone methods, right? So we decided here in this work to try this combination and test if the combination is really produces better results. So the combination here in this work was defined by a vector of integers, as you can see in this example. Here we have the integers difference from 0 represents any specific sampling algorithm. Here we have 4 meaning OSS, 1 meaning near miss, and so on. And 0, the absence of the algorithm in the pipeline. So as I told you, we give an imbalanced data set to this pipeline, and the imbalanced data set is balanced in each layer, right? So we have a pipeline of sampling algorithms, and the imbalanced data set across all the layers. And the output is a balanced data set that was balanced by each algorithm in the pipeline. As you can see, there are many different combinations of sampling algorithms, right? This is just one example, one combination, possible combination. So this is a combinatorial problem. And for that, we use an optimization algorithm called genetic algorithm to evolve solutions iteratively and give us a best solution, a best pipeline for a given balanced data set for us to test to use the classifier to test if the balanced data set is good or not, right? So we created a hybrid in an optimized method for a given imbalanced data set, give us a balanced data set in the end. Okay, talking about the results, I divided the presentation of the results by research question. The first research question is about the cross-language classification. Our classifier achieved 67 classification accuracy, right, and Cohen's kappa of 53%. Okay, according the paper of LIWC and Coh, this is considered a moderate inter-rater agreement, right? Okay, considering regarding the research question 2, feature importance, here we have a table, right, with the most relevant features that for the classifier that we found. Here we have just 16, but we have a table in the paper with the top 20 important features. And here we have many, in majority, features related to LIWC, right? Most of them are the same that happen in the work of the Neto et al. But here we have a majority presence of features related to LIWC. This feature is used to identify triggering events. We will see the consequences of it in the next results. In Neto et al., the presence of Coh-Metrix features are in majority, right? So we have some overlapping here, but this difference happens. Well, here we have some results about the research question 3, where we evaluate the use of our GA class balancing in contrast with no balancing methods and smooth methods, right? When we don't use a sampling method, the accuracy was 59% and the Cohen's kappa 32. When you use the smooth, the accuracy was 53 and the Cohen's kappa 28. In the last, we have our method that achieved the 67 accuracy performance and the Cohen's kappa 53, right? As you can see, the method that was proposed here improved both performance metrics, and it is a good alternative to balance the data sets. Let's give a deeper sight about the results. Here we have the confusion metrics of the no class imbalancing and smooth class balancing, right? As you can see, we have a similar behavior, a similar number of hits per class. The classifier was able to reach good results in just 2 classes, the other class and the exploration class, right? The integration and resolution when we have no class balancing, they are very difficult because the resolution, at first, we don't have too much instances in the data set. So it's difficult to train and test, right? Considering the integration, most of the instances from integration were assigned to exploration phase. As I told you before, one message can express different phases. So as exploration and integration, many words are used to compose a message. So this may contribute for the misclassification. Considering the smooth class balancing, we have a similar behavior, right? In the smooth class balance, we identified more Coh-Metrix features. So the Coh-Metrix features are used to identify more integration messages in integration phase. So the misclassification here was also identified. Right. Considering the table of our method, sampling method, we can see that the order in the exploration phase, the number of hits that the classifier was able to identify is a little bit similar when compared to the last 2 tables. But we can see that considering the triggering events, the classifier was able to identify to hit more instances correctly. This can be explained because of the number of features related to the LIWC, right? So the classifier was able to hit more instances in this class. Okay, to conclude this work, we can see that the results showed a substantial performance in cross-language classification, right? According to our knowledge, this is the first work that tried to use an English dataset, for example, to train a classifier and test in a different one. So the results show to be promising, right? Certain elements of cognitive presence translate accurately between different languages. And as I said before, this opens up an exciting avenue for further research, mainly non-English online education practices, right? Right. Our work has some limitations. Although our data set was larger when compared to other data sets, it's still small, right? We have to try to increase the number of instances, label more instances, consider bigger data sets to make more accurately results. Also, the data came from only 2 courses. The English course considered 6 classes, and the Portuguese course considered 1 class. So the results might have been affected by the intricacies of the designs of the courses. And also, we want to improve the misclassification, right, of integration and resolution phases. As future work, we intend to extend the current work by providing additional data sources for Portuguese and English languages, identify features that can describe better the later stages, like integration and resolution, yes, explore additional languages like Spanish, deploy these models in practice to provide insights in their use to support teaching and learning, and also examine in greater detail the performance of this method and the effectiveness of this method in other classification tasks regarding the learning analytics, right? The learning analytics area. Well, I think that's it. I hope that I made myself understandable. Thank you. I'm here for questions.